Swayam Prabha. Digital India. Educated India.
Welcome back to Mechanics and Control of Robotic Manipulator. So far last class till now, so what we have covered is basically like a trajectory generation. So the trajectory can be generated using several, you can see, generation schemes. Even there are several methods of generating in robotic manipulator. So this particular class we are going to see how we can generate a trajectory by using different you can say polynomial function or cycloidal function and all. So that too, like with the help of Matlab we are trying to do. So in that sense we are trying to see in this particular short lecture we are going to see third order polynomial. So where the cubic polynomial function as the trajectory generator, and in that we would be seeing additionally like with via point. Even the via point we have seen like the via point velocity is specified or not, how that can be. So if that is the case, we will go to the you can say scenario. So where the cubic polynomial function or the third order polynomial function will give the displacement, velocity and acceleration in this form. So where you can see this is the displacement and this is the velocity and acceleration. So these all can be written in this way. So where t naught conventionally we assumed as to be 0. Even the t naught is something, so we will actually like add the t naught whenever there is a need. So in that sense we will actually like rewrite this equation if t naught is 0. So we can rewrite this equation in a matrix and vector form. So where the a naught, a1, a2, a3 are actually like unknown. So the initial you can say and final conditions, both displacement and velocity, all are actually like known to us. So in the sense these are known input and these are unknown and these are the coefficient. Again the coefficient matrix are known, which would be function of TF or the constants. So now once you know this all, so what we can do, we can write a Matlab code and we try to generate, and then we can actually like try to generate whatever we have written as the cubic or third order polynomial function and try to see whatever we have seen in the lecture is following or not. So for that we are writing the Matlab code. So we know like the initial is actually like straightforward syntax. So where the clear all, see you can say clear the command history or close all, these are actually like standard because we are going to run you can say figure windows and all, so better we need to close. So then you can see that the trajectory inputs we need to give, where the trajectory inputs are actually like one is the final time and we always assume that t naught is 0 in this case. So then the time span we start from t naught to tf, the t naught we assumed as 0. So this is what the trajectory input of the time. So further you know like x of 0 and x of tf and x of x dot of t0 and x dot of tf all are actually given. So now these all actually like we assume to be known. So now these are actually given and assumed to be known. Then we can actually like write the coefficient matrix what we derived here. So that coefficient matrix we have written here. So now what else we need to like talk about, what is the you can say this known value that I will write as a b vector, and this I am going to call as actually like tc vector. So in the sense trajectory coefficient vector. So now in that sense you can see like this is the known input which is I written as a b you can say b vector. So which is initial you can say position, initial velocity, final position and final velocity, which we have written in the standard syntax. So after that the trajectory coefficient can be found. So there is a f is missing. So like this is co f, it is f is double. So anyhow it's actually like comment, it's not a problem. Then the trajectory coefficient can be taken in this form. So once that is done, so then you can see like x dot and x double dot written in this way. So here I don't want to write x dot x double dot, I have written x which is actually like position, v is the velocity and a is the acceleration. So this is what the equation which we obtain. Okay. So once these all done, so what we can do, we can actually like plot the trajectory. So where we can actually like see the x trajectory, v trajectory, a trajectory we can plot and then see it. So in that sense, we can actually like go to the Matlab and try to see how this can be done. So for that I'm actually like opening the Matlab. So you can see like this is what we have written. So the initial position is actually like you can see instead of giving theta naught and theta you can see the case. So I'll just check that. So yeah, so cubic sample, right? So we can actually like see that instead of giving that, we are giving the x naught and xf, and the xf dot and x naught dot as given. So these are actually like standard. So only thing is actually like we can make it. So now we are actually like taking this B and then TC we have done, and this matrix whatever we have obtained the CA, from there you can see this is what the time base. So now this we can convert into T of I. So that is what the relation, and this way we can actually like write velocity and acceleration, and we can actually like a plot in this way. So in that sense, if I run this code, so we can see like it is starting from, you can say 0 and it goes 5, and the velocity is actually like starting from, you can see like -1 to end with 1 units. So the total finite time is actually like we start from 0 to 5. So we can see all those things in the Matlab you can say running. So I have run this, and you can see like now there are 3 things. So you can see like this is the x, so x of time, this is actual time versus the eta of t. Eta of can be written as x, x dot and x double dot. So now you can see the blue curve is actually like x. So x of t is actually like vary from 0 to 5 in a cubic polynomial form. So this curve is actually like very bent because there is a non-zero initial velocity which is -1 you can say units. So that's why it is actually like going in that curve manner. Similarly, the acceleration, you can see like acceleration we don't have control, but the acceleration is actually like finite at the initial and as well as finite at the end, in the sense constant acceleration and deceleration in the initial and final. That way we can see in the sense non-zero initial and final acceleration. So now in order to get more clarity, so for example I am just making the initial and final velocities are 0 just for understanding. So you can see like now the curve would be a little different. You can see like it is smooth, and again you can see the maximum velocity is actually like happening at the middle, which is 2.5 here, and the acceleration is actually like 0 at that point. So that way we can actually like look at, now the curve is actually like you can see it is going much more smooth. The other one is look like a non-minimum phase system, so I don't want to bring that unnecessarily complicated term. So this is what the idea. So now even if I actually like change the time step, you can see that I'm just giving only TFS 2. So now you can see like it is actually like compressed. So now the concept you can actually like see it, it is actually like modified. Within 2 seconds it is starting from 0 to 5, it is maintained, but the correspondingly you can see the acceleration increase because you have reduced the time span, and the velocity also like increase. Now it is approximately 4 units. That's what you can actually like see approximately. So now you can actually like even do it probably higher, then you can see that the acceleration and the velocity would be getting decreased. However, 0 to 5 you can actually like see it, right? So these all variations you can actually like try. So instead of this, if I actually like try to give, if for example this is starting from 2, so and I am actually like making it, this is actually like 5 seconds. So even you can actually like feel it, it is starting from 2 and it actually like end at 5. So now you can actually like see how the velocity and acceleration is going on. So now you can see like obviously there is no control over the acceleration, only maximum you can do the velocity. For example, now this is point when it started and end with I wanted 1 meter, or you can say 1 units. So now I am actually like trying to rotate, trying to run. You can see like it is starting from you can see final is actually like 0.1 and the initial is actually like you can see something around what you call Z1, right? So that is what it is actually like trying to happen. So now this all happening. So now you can see like it is starting from 1 and it is actually like a move to 1.1 because so you have actually like starting from 2 to 5. So that is the case. So you can actually like get it. So now in order to make it clear, so I'll just make it the 0 and this is also 0. So now you can actually like see it is actually like much more smoother than the earlier. This is what one such. So you can actually like see it this all, right? So now we'll go back to what you call the Matlab. Before that, I'll just open it. So what is called the cubic. Okay, these all I just better open so that it would be easy for us to come back. Okay. So now I am actually going back to the slide. So you can see like the second thing is what we are trying to cover is cubic trajectory with via point. So in the sense it is actually like a segment. So for understanding here I have taken only two segments. In the sense there is a via point which actually like denote correspondingly the time is TV. So the profile or the trajectory start from T0 to TV, which is actually like the first segment. Then the TV to TF is the second segment. So in that case, so the trajectory can be written in this form. Okay, this is the first segment and the second segment. Now there are two cases can come. So where the you can say via point velocity is specified. So then it would be giving 8 equation and 8 unknowns. So invariantly we can actually like consider each segment separately, because the final velocity of the first segment would be the initial velocity of the second segment. However, actually like there would be a slight transition happening between, you can say, acceleration. That is what we have seen in the lecture. So in that sense, one is actually like with the specification, the via point velocity is specified. However, we assume that T naught is 0. So in that case, the equation will give 8 equation. So I assume that the first segment is actually like A naught to A3 as the coefficient. The second segment start from B naught to B3. So you can see like the XV and XV dot. So these two are actually like the second segment initial position and velocity. So in the sense invariantly it is actually like going to give 6 valid equation, but that 6 valid equation we can make it as a 8 valid equation with 8 unknowns. So in that sense we can calculate this. So based on this, what one can actually like look at it. So the code we can rewrite. So now we are actually like writing this via point. So this we have actually like brought it. So via point you can say position and velocity we have added further than the other one. So now the via point time also we have given. So these are the changes which we made from the existing code. And then the coefficient matrix, earlier we have seen it is only 4 cross 4, but in this case I am trying to make it everything in a single segment. So it is going to be 8 cross 8. So further the B vector would be again 8 cross 1. So that we have actually like added, and we are actually like calculating the coefficient. Now the first 4 coefficient would be equivalent to what you call the first segment. The you can say 5th term to 8th term would be related to second segment. So that is what you can see. The first segment is actually like up to TV. The second segment is actually like after TV till TF. So the coefficient is actually like 1 to 4 for the first one and 5 to 8 for the second one. So the remaining all are actually like same. So the plotting functions and all same. So now in that case, so we will take the velocity specified. So we can actually like see this is actually like the function which we have written in the even slide. So you can see now the via point you can say given. So in that sense the via point time, or you can say when the first segment is supposed to be end. So that point is given, and the second segment is actually like end 5 seconds from 0. Okay. So then you can see like we have added the via point position and via point velocity. So here I just want to give you can say non-zero velocity. You can see how it comes. So after that you can see like this is the coefficient A matrix which we have shown in the slide, and this is the B vector. So which is again actually like we have written, and the coefficient we have calculated. And now you can see the first segment is actually like coefficient of A0 to A3, which is TC 1 to 4. And the second segment is actually like B0 to B3, which is TC 5 to 8. So here the second segment start from actually like TV till TF. So that's why the TFI minus TV would be equivalent of that second segment. So indirectly you can see this is actually like first segment separately we have taken a cubic polynomial, and the second segment again another cubic polynomial, and we stitch. That is what we are actually like done. So in that sense if we run this code, so you can actually like get clear. So we will actually like run this. So it start from, you can say 0 and 5, but there is a via point. So you can see like this is with velocity specified. So where the velocity is specified to 1 meter per second, for example, if we consider as position, linear position, this is equivalent to 1 meter per second. So the correspondingly it moved 2 meter, and the second segment it is actually like moved next 3 meter. So the velocity is modified. So initial and final velocity we have given 0. You can see like there is a jump in the velocity. However, it is actually like smooth. But if you look at the acceleration, it is actually like sudden, you can say jerk, in the sense it is actually like non-smooth. So the first segment end with acceleration is somewhere here, and the second segment the acceleration start from here. So this is actually like unexpected. That's why we said it is non-smooth. If your actuator is capable enough, then we can go with this. Otherwise, we have to go for something like with no velocity specified. So even just for iteration, we can actually like modify. For example, this via is actually like I modified to 3, and the velocity at the via point is actually like I put it 0.5, and the via point is actually like only 1. Okay, just I am giving an idea. So in the sense, first you can say 3 seconds it moved only 1 meter distance, and the next 2 seconds it moved actually like 4 meter. It is actually like quite unrealistic. Still we can see how it goes. You can see, right? The velocity, or you can say the cubic polynomial, it is actually like first 3 seconds it is a cubic, very smooth. Then it is actually like another smooth. The velocity also like going like this and then going. However, the acceleration you can see it is very small, but suddenly jerk because you have given the second profile. Okay. So now even actually like for more realistic, so I am just putting it, this is actually like a 3. Okay. And now again I am actually like running this. So now you can actually like see that this would be giving so little different, right? You can see like this giving the segment very explicitly visible, right? So this is what we call with via point, that too like via point velocity is specified. So now coming back to the slide where the via point velocity is not specified, what would be the scenario? So in that case, so this would be having 3 you can say consideration, where you can see like x naught would be given, x dot naught would be given, which is initial position and velocity, and via point position only would be known. Final you can say position and velocity would be obtainable. So from that you will get 6 equation, but the 3 you can say consideration which is involved as an indirect mode, the b naught equal to xv, it is straightforward. However, the b1 and b2 we need to calculate. For that what we take, the first segment final velocity would be equivalent to the second segment initial velocity. In that case, if we assume that the second segment is actually like going to give initial velocity, we start from 0, and the first one is actually like end with the TV. So then you can see like you will end up with the equation like this. Okay. So now this equation is added. Similarly, the first segment final acceleration equal to the second segment you can say initial acceleration, then the 2b2 can be equated like this. So now what happened, the earlier equation is modified. So now still 8 unknowns and 8 equations. So we can actually like bring this A matrix slightly modified. So in this case, the via point velocity is not specified. We have chosen based on actually like the smoothness of the acceleration. So in that sense what we have done, so these all not changed. Okay. So only thing, the via point velocity we have removed from this, and this A matrix modified, and the remaining things all same. Okay. So now these all actually like same. So now in that case we can actually go to the Matlab window. So then you can actually like find it. So this is what the no velocity specified. So you can see like now the velocity is not specified for the via point. So now the A matrix is actually like calculated based on this. Okay. So then the B vector and the trajectory coefficients are actually like calculated in this manner, and then actually like we can actually like end up with so these all. So now if we run the same thing what we have seen earlier case, so we said that the final velocity is 0, initial velocity also 0, and it is actually like the middle point is actually like 2 meter as the displacement, and it takes for 2 seconds. So we will see how this actually like happening. So now you can see like the acceleration is actually like smooth. Earlier you would have seen it is a, you can say, arbitrarily moved, but in this case it is actually like very smooth. So now this is what we have actually like tried to do. Again here you can see the velocities, you can see the first segment end velocity which is equal to the second segment initial velocity. That is what you can look at it. So just for giving clarity, I just make it, the second is 3. So that I can actually like show the, you can say, clear distinguish. So now you can actually like see it, right? So now the velocity is actually like at 3 seconds, you can see like that is the initial and the final. So even I'll just make it this. So I'll just do all iterations so we can actually like see how this is actually like happening. So now I gave 3 seconds and you can see like there is no, you can say, segment is happening, right? So it is actually like much more smooth, everything is actually like smooth. So this is what we call actually like with, you can say, via point, but no velocity specified. So in order to compare, even actually like you can run the same condition. So but only issue is actually like you don't have any velocity specified. So just for benefit, even I assume that this velocity is 0, it is very tricky. So because velocity 0 means it will come 0 and 0. So we can actually like try. So I am not actually like taking away. So we can actually like see so how it goes. So you can see like it start from 0 and end again in the first segment 0 and the second segment is actually again 0. So you can see like it is very clearly say that it is explicitly 2 segment. Okay. So now we say the same case here. So which is actually like the 3 is the segment and you can see there is no via point velocity. The initial and final velocity only we assume 0. So now in that case you can see like the profile is more close like a single cubic polynomial. Okay. So you can see like there is no segment is visible. Okay. So that is what we can actually like feel it. So this is what we call you can say cubic polynomial with via point. Even the same thing can be done for fifth order or some other thing. However, the restriction here we have put it as actually like cubic polynomial is EC, and that is actually like more commonly used profile generation for the you call robotic manipulator and all. So with that we close this particular content here. So the next lecture we are going to talk about the other profile which we have not covered in this particular lecture, like higher order polynomial, cycloidal, you can say you can say parabolic blend and all that we would be seeing in the next lecture. So in that sense, so I hope you are actually like able to follow this. So with that I am saying thank you and see you then in the next lecture. Bye bye.